Hey there YouTube, time for another repair video. Got something a little bit different today. This is actually a fan out of my refrigerator. I think they call it the evaporator fan. And basically, so my refrigerator is a freezer on the bottom, refrigerator on the top. And this fan is down in the freezer and it turns on to blow cold air up to the top of the refrigerator. And this fan died. This is actually the second time this fan has died. And I've replaced it with another new fan, but I'm going to see if I can repair this one, because the fans, they cost like $80 each, and when it fails, no one has the part in stock, so it takes like 3 days. So you're without a refrigerator for 3 days while you're waiting. So I figured I'd take a look at it, see if I can figure it out. And I've already opened this one up. So unlike a pure mechanical fan, this one has electronics in it. And so basically you're going to have a simple AC to DC power supply here, which is then going to drive the motor and spin the stator here, I think they call it. But one thing I have noticed on here, so that capacitor and that capacitor are both bulging. So I'm kind of wondering if it's a simple matter of these two capacitors are what's causing the problem. So I have ordered replacements. They weren't standard sizes that I keep on hand, and we'll go ahead and replace those and see how it works. I don't film a lot of solder work, but I figured I'd give it a try here. That said, I don't know how easy this is going to be. Kind of shows up on camera. The board is very shiny on the backside here, and I forget what it's called. There's a coating they put on here. Since this goes into the refrigerator or the freezer, it'll get cold, and they don't want condensation to short parts out. So there's a coating on here. So I have no idea if that's going to interfere with that, but I've got some solder, I've got some solder wick, and I've got a solder pulp here. So we'll see if this works or not. I always like to go in and add more solder initially, at least. Might even be able to just pull it out. There we go. Let's get that one out and we'll clean up the excess solder. There we go. And let's get the other side. Two capacitors out. There we go. So I've got the replacement capacitors here, and always when ordering capacitors, make sure that you check the size. Like, since there's a case as this one goes in here, I didn't want it to be too big, so this one obviously will fit in there because that cap's bigger. And then make sure you adhere to polarity. Just kind of bend those leads over. Usually they'll mark on the board like that right there, which is the negative side, so you just line it up with the negative side on the capacitor. And now we solder that in. There we go. So I clipped the leads off and I used some rubbing alcohol to clean up the burned flux. And I've inspected the joints and everything looks good. So next step is put it back in the case and give it a try. So now it's time to test this. I have not tested it yet, but I've gone ahead and put a piece of tape on here so I can see if it's spinning or not. And this motor, it takes mains power, 120 AC. I don't have the harness for it, so I'm doing something very unsafe, but I basically just stuck a cut end of a mains cable in there, and I can go ahead and plug it in up here and see what happens. So here goes. Let's see. Look at that. So it was just those capacitors. Cool. So I'll probably take this back apart. The joint here was originally sealed with a rubber compound to keep hermetically sealed inside. So I'll probably run a bead of silicone around there and then seal it back up. But there you go. Probably like 80 cents worth of capacitors to repair an $80 fan. So now I've got a backup for the next time it fails. Well, hope you enjoyed this. Thanks for watching.